Bismillahirrahmanirrahim. Assalamu alaikum dear students. Today is our fifth lecture of Power Generation System course. This course is included in the curriculum of BSc Electrical Engineering Technology third semester, and I am Engineer Mohammad Faisal Khan, Coordinator and Lecturer, Department of Technology, Saraj University, Peshawar. The topic of lecture 5 is the classification of hydroelectric power plants. The hydroelectric power plants may be classified into the following four categories, or according to the following four categories. Number A, classification according to the extent of water flow regulation available. Number B, classification according to the availability of water heads. C is the classification according to the type of load supplied. D is the classification of hydroelectric power plants based on the installed capacity. So let us discuss the A is the classification according to the extent of water flow regulation available. According to the extent of water flow regulation available, the hydro power plants may be classified into runoff river power plants without pondage. Number 2 is runoff river power plants with pondage, and the third one is the reservoir power plants. Let us discuss all these three types in detail. So number 1 is the runoff river power plants without pondage. Some hydropower plants are so located that the water is taken from the river directly and no pondage or storage is possible. Such power plants are called runoff power plants without pondage. Such plants can use water only as when available. These cannot be used at any time at will or fit any desired portion of the load curve. In such plants, there is no control on the flow of water. As you know that during high flow and low load periods, water is wasted, and during the lean flow periods, the plant capacity is very low. As such, these plants have a very little farm capacity. At such places, the water is mainly used for irrigation or navigation, or power generation is only incidental. Such plants can be built at a considerably low cost, but the head available and the amount of power generated are usually very low. You know that during floods, the tailwater level may become excessive, rendering the plant inoperative. The main objective of such plants is to use whatever flow is available for generation of energy, and thus save coal that otherwise be necessary for the steam power plants. During the high flow periods, such plants can be employed to supply a substantial portion of base load. I hope you have understand that there are such plants that have no pondage or storage, and it mainly depends on the water availability according to the weather or season or rainy season. Number 2 is runoff river power plants with pondage. The usefulness of runoff river power plants is increased by pondage. Pondage refers to the storage at a point which makes it possible to cope hour to hour with fluctuations of load throughout a week or some longer period depending on the size of pondage. With enough pondage, the farm capacity of the power plant is increased. So such type of power plants can be used on the parts of the load curve as required within certain limitations, and is more useful than a plant without pondage. This is very important point, that these are very useful than the plants without pondage. Such power plants are comparatively more reliable. These are more reliable, and its generating capacity is less dependent on the available rate of flow of water. Such power plants can serve as a base load or peak load power plants depending on the flow of water or stream. During high flow periods, these plants may be used as base load, and during the lean flow periods, these power plants may be used to supply peak loads only. When providing pondage, tail race conditions should be such that floods do not raise the tail race water level, and thus reducing the head on the plant and impairing its effectiveness. Such plants offer maximum conservation of coal when operated in conjunction with the steam power plant. So this is very important point. The third one is the reservoir power plants. So when the water is stored in a big reservoir behind a dam, it has been studied that we construct a dam, so a reservoir is formed behind the dam. It is possible to control the flow of water and use it most effectively. So storage increases the farm capacity of the power plant, and it can be used efficiently throughout the year. Such a plant can be used as a base load or as a peak load power plants as per requirement. It can also be used on any portion of the load curve in a grid station. Most of the hydroelectric power plants everywhere in the world are of this type. Such power plants are your Reservoir Dam and Tarbela Dam and all these dams, because most of the hydroelectric power plants everywhere in the world are of this type, that you form a dam and it has a big reservoir. Number B is the classification according to the availability of head. So the power plants are also classified according to the head available. According to the availability of water head, the hydropower plants may be classified further into three categories. A is the low head, B is the medium head, and the C is the high head power plants. Though there is no definite line of demarcation for low, medium and high heads, but head below 30 meters. Remember that the head having height of 30 meters is considered low head, and the head above 30 and below 300 meters is considered as medium head, and the head having above 300 meters is considered as high head. So number one is low head electric power plants. Typically, low head installation on a river consists essentially of a dam across the stream to back up the river and create a fall. The water flowing through the turbines in a re-merging the river below the dam. A dam or barrage constructed across the river creates the necessary head. The power plant is located near the dam, and therefore no such tank is required. This is important because due to the low head there is no need of installing such tanks. Either one half of the barrage has regulating gates for the discharge of surplus water, while the plant is in front of second half, or the plant is constructed by the side of the river. So in low head power plants, Francis propeller and Kaplan turbines are used and employed. These are the medium head hydroelectric power plants. In these power plants, the river water is usually tapped off to a forebay on one bank of the river, as in the case of the low head plants. From the forebay, the water is led to the turbine through penstoke. Through penstoke, we allow the water to flow towards the turbine. The forebay provided at the beginning of the penstoke serves as a water reservoir for such power plants. In these plants, water is usually carried in open channel from the main reservoir to the forebay and then to the turbines through the penstoke. The forebay itself serves as a surge tank in this case. So this is important. The forebay itself serves as a surge tank. In these plants, horizontal shaft Francis propeller and Kaplan turbine are used. For medium head, it is important to learn that the horizontal shaft Francis propeller or Kaplan turbines are usually used. Number 3 is the high head hydroelectric power plants. So if the high head is available, a site may be chosen where a stream descending A steep lateral valley can be dammed and a reservoir for storage of water is formed. A pressure tunnel is constructed between the reservoir to valve house at the start of penstoke to carry water from reservoir to valve house. For heads above 500 meter, Pelton wheels are used, while for lower heads, Francis turbines are employed. Okay. Number C is the classification according to the type of load supplied. So according to the load supplied, hydroelectric power plants may be classified into further three categories. One is the base load, peak load, and the pump storage plants for the peak load. Base load plants. The plants which can take up load on a base portion of the load curve of the power system are called the base load power plants. Such plants are usually of large capacity, since such plants are kept running practically on block load, the load that is practically constant. The block load is also known as that load which is constant. Load factor of such plants is therefore high. Runoff river plants without pondage and the reservoir plants are used as base load plants. 2 is the peak load plant. So plants used to supply the peak load of the system corresponding to the load at the top portion of the load curve are called the peak load plants. Runoff river plants with pondage can be employed as peak load plants. If the pondage is enough, a large portion of the load can be supplied by such a plant if and when required. Reservoir plants can be, of course, be used as peak load plants also. Peak load plants have large seasonal storage. They store water during off-peak periods and are operated during peak load periods. Load factor of such plants is low. 3 is the pump storage plants for the peak load. So this is a unique design for peak load plants. Pump storage are not energy sources. Instead, they are storage devices. Water is pumped from a lower reservoir into upper reservoir, usually during off-peak hours. The water is pumped from the lower level to the higher level during off-peak periods, while the flow is reversed to generate electricity during the daily peak load period or at other times of need. Although the losses of pumping process make such a plant a net energy consumer, the plant provides large-scale energy storage system benefits. Pump storage is the largest capacity form of grid energy storage now readily available worldwide. 4 is the classification of hydro power plants based on the installed capacity. So we also classify the hydroelectric plants according to the capacity installed capacity according to the load. So apart from the above other classification, the hydropower plants can be also classified on the basis of installed capacity as large, medium, small, mini and micro hydropower plants. Generally, the mini, micro and pico hydro come under the subcategory of small hydro plants. These are briefly described as below if you look at the table. So large hydro. What is large hydro power plant? If you classify it according to the installed capacity, so exceeding 100 megawatt and usually feeding into a large grid. If a power plant has a generating capacity of 100 megawatt or more than 100 megawatt, so these are included, these are categorized as a large hydro. And the second one is the medium hydro, which is from 15 to 100 megawatt. If you have the generation of the power plant between the 15 and the 100 megawatt, so they are usually considered as medium hydro. And the small hydro generation capacity is 1 to 15 megawatt. If you look at here, usually feeding into grid, and these are all feed it into grid. Mini hydro is considered as if you have a generation capacity of 100 kilowatt to 1 megawatt. So either isolated or feeding into grid. These may be used as an isolated form of hydropower plants, or it also feed it into the grid. The fifth one is the micro hydro. If you have a generation capacity of 5 kilowatt to 100 kilowatt, so these are micro hydro, and these are usually provides power for the small community or rural industry in remote areas away from the grid. And the last one is the pico hydro. From it has a generation capacity of few hundred watts up to 5. So pico can also be used for domestic and domestic use. So these are all the classification of hydroelectric power plant based on the installed capacity. So nowadays we have many dams across the world are large hydro or medium hydro, or low level, or the places or the remote areas away from the grid, there are used micro hydro power plants. So apart from the above said classification, there is also a class of very large hydro power plants coming up with the capacity ranging from more than 5000 megawatt up to 10,000 megawatt due to the large scale investment and better technology available. However, as far as the small hydro is concerned, the upper and lower limit varies from country to country, where while defining the small hydro, there is a general tendency all over the world to define small hydro by power output. Different countries are following different norms, keeping the upper limit ranging from 5 to 50 megawatt. So these were all about the classification of hydroelectric power plant. If you read this lecture, if you have any questions, so we will discuss it in online meet class tomorrow, inshallah. Thank you very much.